In this question, we determine the values of t such that the curve is concave upward. So here we utilize the fact that the curve is concave upward whenever its second derivative is positive. That is d2y by dx squared. And whenever it is greater than 0, we say that the curve is concave upward. So we have to determine the second derivative of the curve and determine the values of t such that it is positive. So let's see how to find the second derivative. Notice that we are given the parametric equation of the curve in x as well as y. So first we find the first derivative, that is dy by dx, using the formula, that is we have dy by dt and divided by dx by dt. So we have to find dy by dt and dx by dt and find this quotient. So let's find dx by dt using this parametric equation, x equals t squared. Differentiate both sides with respect to t. So we get dx by dt, and this equals the derivative of t square with respect to t is 2t. This is using the power rule. Now let's find the derivative of y with respect to t. So here we have y equals 1 minus of natural logarithm of t. We find its derivative with respect to t. So I write dy by dt, and this equals derivative of 1 is 0, and derivative of natural logarithm of t is 1 over t. So it is negative of 1 over t. And therefore we can now determine the first derivative of the curve, that is dy by dx. So let's substitute the values of dy by dt and dx by dt. So we write the first derivative of the curve dy by dx, and this equals dy by dt, which is negative 1 by t, and this is divided by dx by dt, which is 2t, and so this equals negative 1 by t times 1 by 2t, and so this equals negative of 1 by 2t square. We now find the second derivative of y. So we write d2y by dx squared, and this basically is the derivative of dy by dx. And since this dy by dx is basically a function of t, we write down this as d by dt of dy by dx, and then applying the chain rule, we find the derivative of t with respect to x. That is, we multiply with dt by dx. This is dx. Or otherwise, we can write this as divided by dx by dt. So I write down d by dt of dy by dx, and this is over dx by dt. So basically, this is the formula to find the second derivative of y when we are given the parametric equation. So we can find this formula. And in the numerator part, we have to determine d by dt of dy by dx. That is, we have to differentiate this dy by dx with respect to t. And in the denominator, we should find dx by dt. Dx by dt we have already found, which is 2t. So we should only find the derivative of dy by dx with respect to time. So let's do that. So we find d by dt of dy by dx, and so this equals d by dt of replace dy by dx with negative 1 by 2t square. So first we write down this as a power of t. So this is negative 1 by t. This 1 by t square is written as t raised to the power of negative 2. Now we differentiate this with respect to t. So I put this negative 1 by 2, and then apply the power rule to find the derivative of t power minus 2, which is negative 2 times t raised to the power of negative 2 negative 1 equals negative 3. We now see this, we can cancel this negative 2 with this 2 as well as this negative, because the product of two negative is positive. So basically here we get 1, and 1 times of t power minus 3 is t power minus 3, or this equals 1 divided by t. And we have determined the numerator for the d2y by dx squared. So let's plug it here. So I plug in 1 by t cube for the numerator, and divided by the denominator is dx by dt, which is 2t. So I'll substitute 2t here. And so we can simplify this equals 1 by t cube times this is 1 over 2t. And so this equals 1 over 2 times of t cube times t is t power 4. So this is the expression for the second derivative, that is d2y by dx squared. And now for this to be greater than 0, we can plug in any value of t, because if we plug in either positive value of t or negative value of t, this is always going to be positive irrespective of the value of t. Since here we have the expression t raised to the power of 4. So if we plug in a negative value, say for example, if we plug in negative 2, it's going to be negative 2 raised to the power of 4. And this is basically equivalent to 2 raised to the power of 4, which is positive. And if we plug in t equals to 2, it is 2 power 4, and this is positive. So it's going to be positive for all values of t. So therefore we see that for all values of t, the curve is concave upward.